In our 5.2 here, we are doing compounded continuously. If you remember doing this in pre-calc, we did compounded different times, like yearly, semi-annually, daily, monthly, all of that, which is all the things that we use for n, and we did that. Continuously was this thing where it's compounded by a computer, and it's just continually adding in your interest, which means you really can't state like a number of times per year that it's happening. And so it gives you this PERT formula, which is one of those things that you remember from Algebra 2 or pre-calc. However, I told you we could do everything in our calculators, and that still stands true for this. It just takes a little bit of careful knowing what you're putting where. So when we are doing compounded continuously, a couple things are true for that. In only compounded continuously, n is just number of years. Okay? This is because in every other one, we say n is the number of years times the amount of times it's compounded that year. Can you say the number of times it's compounded when it's continuously? No. Okay, so in this one, you make n the number of years. The other careful programming thing that you have to do is this is where that py is 1, but you can make cy a different number. And so what we do for cy is we make it a really, really, really big number. It would be like typing in like a billion. But you don't want to type in a billion every time. And so what we do is we just do 1 times 10. And I know it works to the 11th power. It probably doesn't matter that it's 11. But like I know that works, so I just use that every time. You know what I mean? So that I don't have to be super thinking about what I'm doing or how many zeros I'm typing. I just do that every time for compounded continuously. So in something like example 1, we are investing $100. So what is that in my calculator here? My PV. And I'm investing 100, so it goes in as negative 100, right? All right, so like I said, we were doing investing $100, and investing means negative 100, right? Oh my word, why is this not working? All right, so things we need to have in there. We are investing $100, which goes in as negative 100. We are still not having a payment. We are finding the future value, and it says after how many years? The first one is 1 year, so we do n is 1. Now, down here, when we put in the numbers for PY and CY, when we did this last class, I told you whatever you put in for the first one, like if I make that 1, it will then change the second one to 1. It doesn't work the opposite way. So if you want that PY to be 1, we need the CY to be that really big number. And so I'm literally just going to type 1 times 10 to the 11th power.
Why are we doing that again?
It's basically making your calculator think that it's compounding like a million or a billion times a year, which is the closest we can get to continuously. Like continuously essentially is like infinite, which we really can't do that. So this is faking your calculator into thinking it's enough times that it's close enough, basically, because there's no way you can put in infinity for that. So that just says enough times that the rounding error isn't a problem, and we get a correct answer, essentially. So this is just for compounded continuously. So what are we solving for? Future value. So with that highlighted, we hit alpha, enter, and that gives me $105.13. Now, that's not a lot of money. We didn't invest a lot, so you're not going to get a lot back out. Okay. The only difference between A and B there is the amount of time. So in this case, all I'm going to change in this one to do it one more time is what? Yeah, the number of years. So in this case, that's just my n. So n is going, so with n being 5, we get more money, $128.40. Okay. We're going to come back to example 2 in just a minute. Let's take a look at example 3 while we're still in the same solver. If I read example 3, it tells us a trust fund is being set up by a single payment. That tends to make us suddenly think we should use the payment thing. But a single payment, this is just what you're putting in at the beginning. So what is that? the present value. So this one, we said we are investing a single payment. We don't know what it is. So that at the end of 20 years, there will be $25,000 in the account. So what is that? My future value, $25,000. And we were given 20 years. So N is 20. If interest is compounded continuously, which means we do PY is 1 and CY is the really big number, at a rate of 7%, how much money should be paid into the fund initially? So again, we're solving for PV. So solving for our present value, alpha enter, we find out that we need to invest $6,164.92 in order to have $25,000 at the end of the 20 years. All right, so for example 2, we're going to quit out of our solver because we're not going to use our solver right now. We used a couple other commands last class, that effective rate and nominal rate. You can use that as well with this, and I'll show you what that looks like, which will essentially be this, but I'll show you how to do that. In example 2, it says find the effective rate that corresponds to an annual rate, which is like a nominal rate, of 5% compounded continuously. So this is where we use that other command in our finance section. So under apps, where's my mouse? There we go. All right, so under apps and finance, instead of choosing our solver, this is where we go down. We want to find the effective rate. So I find the one that says EFF, which is all the way down at C. And remember, this command required us to put in the rate, or the interest rate first. So that drops this in here. What interest rate are we starting with? This is example 2, yeah? So 5% compounded continuously. Yesterday, last class, we would say compounded monthly, so we would put in 12. Compounded quarterly, so we put in 4. If it's compounded continuously, this is where we can fake the calculator out again if we put in a really big number. So instead of putting monthly as 12 or quarterly as 4, this is where we again can do our 1 times 10 to something like the 11th power. And we can ask our calculator and fake it out to make it a really big number. And it gives us our effective rate for compounded continuously, which is about 5.13%. You can also use that nominal command, if given an effective, to go backwards. And you can still use that 1 times 10 to the 11th power. Like I said, I use it enough that I just stick with the same number. Okay? All right, what questions do we have about compounded continuously? Just make sure you have written down somewhere like what you need to put in specifically for compounded continuously, and you'll be fine with that. That's not a big problem. All right, so if you flip the page and look at the top, it says annuities, okay? Annuities may be something you are not super familiar with, and so I'll give you like the very basic explanation of what the heck an annuity is. And again, keep in mind, this is me teaching a business class and I've never done this in my life, okay? So I know the basic idea of what an annuity is. Also, please take a moment with me and look at the top of 120 and those stupid formulas that don't look like they make any sense. And appreciate the fact that we're going to be doing this in our calculator with no formulas or things with bars on it that don't make any sense to us, right? We're good with that. So an annuity can work one of 2 ways. One way, so this is an investment type. It's not super common anymore. I'm not sure why. However, it can work one of 2 ways. You can put in a big chunk of money at the beginning, and someone will invest the money for you, and it will make money on your money. But what you do is instead of investing it and taking it all out at the end, it's set up so that you get a certain payment out every so often. Sometimes people set up trust funds this way. Like if a parent dies, let's say, they can set up an annuity so that their life insurance goes into this. I know it sounds funny. My sister-in-law, that happened to her. And she gets X amount of money once a year out of this annuity to help her and her mom like live on that. And that's something people set up for like if someone dies. Or the other way you can set it up is you can make it as an investment thing for yourself. Let's say that you do not have a lot of money to put into an investment right now, but you could put a little bit every month. This is pretty common at this point. But you can do a payment of, well, let me just use the example, like my kids' college funds. Your parents probably do this too. I have a college fund for my kid, and I can't like put in $20,000 now and just hope for the best for later because I don't have that money. What I can do is I can put in $150 every month. And so that's a payment into an annuity. And what's going to happen is at the end of whatever this is, I'm going to be able to take out a big chunk of change. So it either works one of the two ways. You put a lot of money in at the beginning and take payments out to help yourself live, or you put payments in and take a big chunk out later. And so that's what you're going to see in these examples. We'll just do a couple of them to make sure we can solve. But this, if you want to write on your notes, is where that payment stuff starts coming in. Remember I told you we were going to bring the payments up later. So there's going to be two things, and I know these are not your notes, but just kind of to make myself a note here. We're going to start using these payments. It's either going to be payments in, and then you'll get money back out at the end. So if you have payments in, you are then going to have a future value, or you'll be finding a future value. Because that's the type that you put payments in all along the way, and you get out a future value at the end. Okay? Or it could be, why is that not even showing up there? There you go. If you're investing in at the beginning, you will have a present value, and you will get payments out. But, no, technology hates me today. Okay. This will be a funny recording now. Great. There it is. Showed up now. So what I need you to know, though, from that is that there's like three things. There's present value, there's future value, and there's payments. You're only going to ever have a combination of the two. You're either going to have payments in with a future value back out, or you're going to have a present value in with payments coming back out. You're never going to have all three. It doesn't work that way, okay? There's also something in your solver that says payments at the beginning or the end. When we kind of notate whether you're going to see it in the wording of the problem, you are either going to pay in at the beginning of the month or the end of the month, and therefore how it is calculated changes just a little bit, okay? So let's all read example 4, and we're going to go back into our solver to do this because we love the solver. All right, so in example 4, find the present value of an annuity. Okay, so we want to find present value, obviously, of an annuity of $100 per month. So when it says that $100 per month, what do you think that is? That's your payment. You're pulling $100 out every month, okay? You do not have a future value then because we're finding present value and we are given a payment. So we are not going to use anything with future value. So my payment is 100, my future value is 0. In this case, then, it tells us 3.5 years at an interest rate of 6% compounded monthly. Now, we've gone back to compounded, like a certain time. So now N is still back to 3.5 times 12. So N being just the amount of years only works for my compounded continuously. And I have to go back to that PYCY and say 12 for both of those. Any issues with our setup?
The payment is at negative 100.
So this one, you're putting money in at the beginning. Mm-hmm. That would be negative, but you're taking money out. So that's positive. So the payment is positive. Now, I will say if you don't know, the future or the present value could come out as a positive number or a negative, but it'll be the right one. Like if you don't know whether to put that payment in as 100 or negative 100, you're going to get the right answer for PV no matter what. Like if I put that in as negative 100, the PV comes out positive. If I put it in as positive, it comes out negative. If it does not say that the payment is at the beginning or the end of the month, we assume end unless it says beginning. So sometimes we will change that to begin, and we'll see that. So now we want to solve for what in this case? PV. So I go back, find my PV by doing alpha enter. Now we're getting used to the point that the PV is a negative number because this is what you're paying in at the beginning. So what this is telling us is if we pay in $3,715.51 at the beginning of this, you would then be able to take out $100 once a month for 3.5 years.
This one's 6%.
Oh, I didn't change mine to 6. Thank you. So wrong answer. Perfect. As I talk, I forget to turn things over. There we go. 3,779? Is that better? All right. So again, if you invest that amount at the beginning, you will be able to take out $100 payments once a month for 3.5 years. Okay? So if I then look at example 5, we are given an interest rate of 5%. So go change that for myself right now. 5% compounded annually. What does that mean for us? One time a year. So my PY, CY is all 1. Find the present value. So again, we'd like to find our present value of an annuity of $2,000. What is that $2,000? That's our payment. So if they say an annuity of something, that is your payment. Due at the end of each year. So now notice the wording is there that they specifically want that to be end for the payment. Oh, I always start reading this one and skip it. We're not going to do 2 different types of annuities. This one says $2,000 for 3 years and $5,000 after. We're not doing that. We're not going to worry about that. So skip to the next page. All right, look at example 6. We can also find the payment amount if you know the present value or the future value, depending on what's happening. So in example 6, it says $10,000 is used to purchase an annuity. Okay, what is that?
PV.
That's PV, because you're putting in $10,000 at the beginning. So go ahead and make your PV, and again, we're purchasing it, so what does that mean? We use a negative. Okay, so in my PV, we make that negative. That is working. These calculators start to work and not work and things. There we go. Negative 10,000. Okay, equal payments at the end of each year. So that tells me my payments should be set to the end. After that, it tells us for 4 years, compounded 6% annually. So what does that give us? We have 10,000 in our PV. What's our interest rate? 6. How do we do our N? 4 times 1, or just 4. I don't know my payment right now, so I'll make that 0. And PY, CY is 1. Which one are we solving for this time? Payment. We're solving for our payment. And so you're only ever going to have present value, find payment, payment, find present value, or payment and future value together. You're never going to have all 3. So you can eliminate the future value. Not going to be a thing. So if I solve for this, if I put $10,000 in at the beginning, I can get out every year, I can pull out $2,885.91. Okay? All right. We'll read 7 together, and I'll get you started on it and see if you can solve it. Another place you see annuities is insurance policies. This is life insurance, a lot of other things like, life insurance. That's the big one. Everyone pays into life insurance. This is life lessons for you. Pay so much a month, and at the very end, or maybe never, you get the money back out. Most life insurance policies are hopefully you never use it, right? So a lot of us pay the money in to get nothing back out, and that's fine. It's just in case. But this one says, premiums on an insurance policy are $50 per quarter. Are you paying that, or are you getting that? You're paying that. A premium means this is what you're giving the insurance company in order to keep your insurance for you.
What if all your direct family dies before you die?
The state. Yes. Actually. We're paying in $50 a quarter. If you're paying that in, how should I make my payment on this one? Positive or negative? That's a negative payment. So we want to put our payment in as negative 50. Okay? This is because this is something we are paying in, and we're going to get money back out now, later. So it's at the beginning of each quarter. So what's quarter telling me? 4 for PYCY. And it's also telling me at the beginning of each quarter. What does this mean?
Change it to beginning.
I change it to beginning. If the policyholder wishes to pay 1 year's premium in advance, what is that? In advance is at the beginning. So what's that? PV. I'm finding PV. How much should be paid provided that the interest rate is 4% compounded quarterly? What should my N be?
1
Times 4. So 4. Yes? And we're solving for PV. So in this case, we say alpha enter. If you were going to pay this up front, you would have to pay $197 to do quarterly payments of $50. You get some interest on it, which is what makes up the extra money that you don't have, because some of you are thinking $50 a quarter for a quarter, all 4 quarters would be $200. The interest rate makes up the extra money. You put it in at the beginning, make a little extra on top of it, pays for the whole thing. Okay? Last ones. I would like to do 9 and 10. I would like you to read 9 and see if you can figure out what to put in. It's pretty straightforward, but just see. And then we will do 10 together. All right, so with all of my information input, my final value at the end is $661.84. Okay. All right, our final thing is a sinking fund, which sounds like we're learning something new, but a sinking fund is just a type of annuity. So it's not that big of a deal. This one tells us a machine costing $7,000 needs to be replaced at the end of 8 years, at which time it will have a salvage value of $700. Salvage value means that you can basically sell off the old one for parts and get $700. That's what a lot of people do with their cars. If it's really completely crap by the end, you just sell it off for parts or for a little bit of money to pay off part of your new car. And so that's what you're doing with the machine. So you sell off the old machine, you get $700 for the old one, and now we need to buy a new one. It says the amount in the fund at the end of 8 years is to be the difference between the replacement cost and salvage value. In other words, you're using that $700 to pay part of the $7,000. So how much money do you really need to have? $6,300. If it costs $7,000, you have $700 from the parts. You really only need $6,300. Okay? So at the end of the time, we need $6,300. What is that in here? That's my future value. $6,300. We know 8 years compounded quarterly, so what should N be? 32. N is 32. What's our interest rate? 8. We would like to know if equal payments are placed in the fund at the end of each quarter. So what's one more thing I need to change? End at the very bottom. What should the payments be? So what are we solving for? Payment. So I will do alpha enter. I need to make payments of $139.65. No?
No.
Lies?
You didn't change the...
But did I not change? Oh, I hit enter on that. Okay. I tried. You would believe how this is actually not that easy to use this from your computer through your iPad. All right. How about that? 142.45? Okay. All right. Now,